Alright guys, welcome back. So this is lesson number 2 for your Form 5 chapter 3. So in the last lesson, we learned some basic introduction. We learned some basic concept for thermochemistry. Yeah, we learned what is endothermic, what is exothermic, okay, what is delta H. Okay, we learned breaking bond, forming bond, energy level diagram, energy profile diagram. Yeah, those are the things that we learned in the last lesson. So in today's lesson, we will focus on calculation. In today's lesson, we will focus on calculation. So there are total 4 calculation for this chapter. In this chapter, which is Form 5, Chapter 3, there are 4 important calculation that we need to know. Okay, the first one is heat of displacement, okay, which is what we will learn today. Then in the next lesson, we will learn heat of neutralization. After that, we will continue with heat of combustion. Okay, then only we will finish the last part, which is heat of precipitation. Okay, so I want you to pay attention for today's lesson, because if you fully understand heat of displacement, you can use the same concept on the other heat as well. Okay, if you can understand the basic idea for heat of displacement, you will be able to understand these 3 very easily. Yeah, because there are so many things is common. There are so many things which is the same. Yeah, all right, so let's start. Okay, since we want to focus on calculation, you need to know that in this chapter, we have 3 formula that we will use to do calculation. Okay, in this chapter, if we want to do calculation, we will always use 3 formula. Okay, so the first thing you need to know, in this chapter, we will use a lot of solution. This chapter, we will have a lot of solution. Okay, we will be given a lot of liquid. Yeah, so you must know how to calculate the mole for solution. Okay, so if you have a solution, you need to know how to calculate the mole. Okay, you learn this in your Form 4 chapter 6. You learn this in your Form 4 chapter 6. Okay, all right, so let's do a quick revision. So this is the formula for us to calculate the mole for solution. Okay, so if you want to calculate the mole for a solution, we use N equal to mv over 1000. Okay, so the small capital N here is the mole that we want to calculate. So the small capital N is the mole that we want to calculate. Okay, the big capital M here is something we call molarity. Okay, we call it as molarity. Molarity, sometimes they also can call it as concentration. Yeah, all right, so the unit for your molarity is mole per dm cube. Okay, so you need to know the unit. Yeah, so after that, the V here is, V stand for volume. This is volume of solution. So volume of solution, the unit is cm cube. Okay, the unit is cm cube. Okay, so watch out the unit. All right, so look at here the side notes. Okay, all right, so in your SPM chemistry, they will always ask you to find the volume for gas and solution. Yeah, they will ask you to find volume for gas and volume for solution. They will not ask you the volume of solid. Okay, I repeat, in SPM chemistry, you will never use the calculation for the volume for solid. Yeah, for chemistry, they will only ask you the volume of gas and the volume of solution. So you must make sure what is the proper unit, because there are many students, they always give the wrong unit. Okay, so please look at here. Okay, look at the left hand side here. So if you have a gas, the unit always go for dm cube. Always give the answer in dm cube if you are looking for the volume of gas. But today, if you want to find the volume of a solution, so if you have a liquid, okay, for the volume of the solution, we use cm cube. Yeah, so this is something very, very important. Yeah, volume of gas, dm cube, volume of solution, cm cube. Yeah, all right, so please be very careful with the unit here. Okay, let's continue. Okay, so now we already learned this. So the first, we have three formula. So the first formula is N equal to mv over 1000. When we can use this formula, we use this formula whenever we want to find the mole of a solution. If we want to find the mole of a solution, we will use this formula. Okay, so the second formula is this: Q equal to mc theta. Q equal to mc theta. If you are taking physics, this is not too hard for you. If you are learning physics, this is not too hard, because this formula also appear in physics. This formula also appear in physics. Okay, so Q equal to mc theta is used to calculate heat change. If the question asks you to calculate the heat change, or they call energy change, we will use the Q. Heat change, the change here can be absorbed, can be released. Okay, if they ask you calculate the heat absorbed, calculate the heat released, okay, they are looking for Q. Yeah, if they ask you calculate the energy that is absorbed, calculate the energy that is being released, okay, so you go to find Q. Okay, so that's it. So I repeat, if the question asks you to find heat or asks you to find energy, they are looking for Q. Yeah, Q, the formula is mc theta. Mc theta. Okay, M stand for mass. Okay, so like what I say, this formula also appear in physics, but in physics it's too, not to say too, it's much more complicated. Yeah, in physics this formula is more complicated. Yeah, in chemistry this formula will be very straightforward. I repeat, okay, we learn about Q equal to mc theta in physics and chemistry. In chemistry, this formula is very, very straightforward. Okay, so first of all, we need to know what do we mean by M. The small capital M stand for mass. Okay, the small capital M stand for mass. Okay, so in chemistry, mass is gram. In chemistry, mass must be gram, not kilogram. Kilogram is for physics. In chemistry, mass must be gram. And how to find the mass of solution, because I say just now, in this chapter we have a lot of liquid, we have a lot of solution. So if you want to find the mass of the solution, okay, you just need to know this. In this chapter, the mass of solution is exactly same as the volume of the solution. So if the question gives you the volume, you can actually use the volume and convert to mass directly. Okay, for example, look at here, the left hand side. If you are given a solution, the solution is 100 cm cube. If the volume is 100 cm cube, so what about the mass? Okay, so remember I say just now, in this chapter, mass and volume is the same. So if the volume is 100, the mass also 100. What is the unit for the mass? Gram. In chemistry, the unit for the mass is gram. That's it. So if you know the volume of the solution, you will know the mass. That's it. Okay, for example, if I have the solution, the volume is 50 cm cube. If the solution, the volume is 50 cm cube, then the mass will be 50 gram. Okay, very simple, very straightforward. Okay, if the solution is 400 cm cube, then the mass is 400 gram. That's it. Okay, so now you should know what is M already. C is heat capacity. Heat is something we call heat capacity. Heat capacity, the value will be given. In exam, they will give you the value for the heat capacity. Yeah, heat capacity normally in SPM, they will give you 4.2. Okay, most of the time they give you 4.2. Sometimes they give you 4.18. Do you need to memorize? No need. So depends on what the question give you. If the question give you 4.18, you use 4.18. If the question give you 4.2, you use 4.2. That's it. Okay, so I repeat one more time. C is refer to heat capacity. Heat capacity, the value will be provided. The value will be given in the question. Normally, the value is 4.2. Okay, so next one. The last one is theta. The formula here is theta. So theta stand for temperature change. Temperature change. Theta stand for temperature change. So now the method for you to find temperature change in physics and chemistry is a little bit different. In physics, if they want to find temperature change, they take final temperature minus initial temperature. Okay, so this is how you find temperature change in physics. But in chemistry, we just need to do this. In chemistry, we just need to find the temperature change by using higher temperature minus lower temperature. Yeah, just take the higher temperature minus the lower temperature. That's it. For example, you have a liquid, initially is 40 cm cube. Now the liquid becomes 70 cm cube. So what is the temperature change? So theta is the temperature change. Take a high temperature minus the low temperature. So it is 30. That's it. Yeah. Just take a higher temperature minus the lower temperature. Then you will be able to find your temperature change, which is theta. Okay. So that's it. So this formula Q equal to mc theta. We use this formula to calculate the heat, okay, or we call energy. So if the question asks you to calculate heat, if the question asks you to calculate energy, this is the formula that you want. Okay? Alright. So the last one here is another one formula. Okay, remember we have three formula here, right? We have three formula. Okay, so I already show you the first one and the second one. Now we go for the last formula. Okay, so the last formula in this chapter is delta H. So remember we learned in last lesson, triangle stand for delta. Yeah, delta H. Okay, so delta H equal to plus minus Q divided by N. Yeah, plus minus Q divided by N. Okay, so now this formula is very important, so I will go through step by step and explain the detail about this formula. Okay, first of all, why they put plus minus here? Why they put plus minus here? Okay, if this reaction is endothermic, then you need to put it positive. So it becomes delta H equal to plus Q over N. That's it. If this reaction is exothermic, then the delta H should be equal to minus Q over N. Get it? So the plus minus here you can change. Yeah, you use plus if the reaction is endo. You use minus if the reaction is exo. Yeah, so this is very, very important. Okay, next one. The Q here stand for heat. The Q here stand for heat, which is what we calculate just now. Yeah, the Q equal to mc theta. After we calculate, we take the Q and put it here. Yeah, all right. So the last one, N, the small capital N here stand for mole. The small capital N stand for mole. Okay, so that is what you need to know. Okay, all right. So far we have learned three formula. So the first formula is N equal to mv over 1000. The second formula is Q equal to mc theta. The third formula is delta H equal to plus minus Q over N. Yeah, so make sure you know when to use. You must be very clear when and which formula you should use. Okay, so if the question asks you to find the mole of solution, you use N equal to mv 1000. If the question asks you about heat change, or the question asks you about energy change, then you go to find Q. You go to find delta H if the question asks you heat of something. Okay, why I put XX here? XX here can be heat of displacement. Okay, heat of neutralization, heat of combustion, heat of precipitation. Okay, so whenever you see the word heat of, so you must calculate delta H. Okay, So this is something very important. Okay, all right. So yeah, so I've already show you all these three formula. I already show you all these three formula. Okay, so the next thing, okay, that we need to know is this. Okay, let's look at the tips. Okay, let's look at the tips. Okay, like what I say, if the question asks you to find the heat, if the question asks you to find energy, you need to find Q. Okay, if the question asks you to find heat of something, okay, heat of displacement, heat of neutralization, for example, if they ask you heat of, you go to find delta H. Okay, another one more thing that you need to be careful is the unit. So in this chapter, you need to be very careful with the unit. Many students, they can do the calculation correctly, they know how to do the calculation, but they still get the wrong answer in the end. Why? Because the unit is wrong. Yeah, everything is correct, only the unit is wrong, then they lose the mark. Okay, so that is very, very wasted lah. So you have to be very careful. Yeah, you have to be very careful. Yeah, so please make sure you know about unit lah. So if the question asks you to find the heat or energy, the unit is joule. Yeah, we learned before in your science, right? In PT3 science, you learn that energy, okay, the unit is joule. Yeah, if you want to find heat or energy, the unit must be joule. All right, so next one, if the question asks you to find heat of something, the unit is kilojoule per mole. Okay, it's kilojoule per mole, which is written as kj mole minus 1. Okay, so this one you have to be very, very careful. Okay, if they want you to find heat, if they want you to find the energy, then the unit must be joule. If they want you to find heat of something, then the unit has to be kilojoule per mole. Okay, so for now you might find it a little bit blur, but you will be fine. Okay, when you go on, when you do many exercises, you will be fine. Okay, all right, so now the next part. Okay, so I will show you total 4 example here. So these 4 example, when you read the question, you must know exactly what we want to find. Okay, and what is the formula we should use, and what is the final unit. Yeah, so this is something very important. Okay, this is something very important. Okay, so let's try to do together. So let's look at the first question. The first question asks me to calculate the amount of heat release, okay, when acid react with alkali. So when they ask you to find heat, okay, when they ask you to find heat, we are looking for Q. Yeah, remember, heat is Q, heat of is delta H. Okay, all right, so what is the formula to find the Q? Okay, the formula is Q equal to MC theta. Yeah, the formula is Q equal to MC theta. Okay, what is the final unit? So we know Q is heat. Heat is a type of energy, right? We want to find the amount of heat. Heat is energy. Okay, heat is one type of energy, right? We have kinetic energy, we have potential energy, we have electrical energy, we have heat energy. Energy, the unit must be joules. Okay, that's it. All right, so that's the first one. So let's continue with the next one, with the second question. So now the question asks you, calculate the energy change when ethanol undergo combustion. So when you see energy or heat, if the question asks you to find energy, if the question asks you to find heat, we are looking for Q. If the question asks us to find energy or heat, we are looking for Q. So what is the formula? Q equal to MC theta. Yeah, Q equal to MC theta. Yeah, so what is the final unit? So energy, unit for energy is joules. Unit for energy is joules. That's it. Okay, very straightforward. Yeah, okay, we go on a little bit more. Okay, look at the question number 3. So now the question asks us to calculate heat of precipitation when NaCl mixed with PbNO3 2. Yeah, so now what is the keyword here? Heat of. When you see heat of, okay, heat of neutralization, heat of displacement, heat of combustion. Okay, when you see the word heat of, you are looking for delta H. When the question asks you heat of, you are looking for delta H. Okay, so what is the formula to find delta H? Delta H is equal to plus minus Q divided by N. Okay, delta H is plus minus Q divided by N. Okay, what is the final unit? Okay, when you look for delta H, the final unit is kilojoule per mole. The final unit is kilojoule per mole. That's it. Okay, so let's continue a little bit more. So this is the last question that we will discuss before we continue with the main concept. Yeah. Okay, what if now the question asks us to calculate the mole of 50 cm cube, 1 mole per dm cube sodium hydroxide solution? So now we are looking for the mole of the solution. So now what we want to find, we are looking for mole of solution. What is the mole of solution? Okay, so we are looking for small capital N. Small capital N is the mole. Yeah, we are looking for mole. To find mole of solution, we use N equal to mv over 1000. Yeah, we use N equal to mv over 1000. Yeah, this is the formula that we use to calculate the mole for solution. Okay, what is the final unit? Since we are looking for mole, the final unit is mol. Yeah, the final unit is mol. Okay, so that's it. So this is the first part. I hope these 4 questions give you a better idea, okay, so that you know when you are looking for mole, when you want to find the Q, and when you want to find delta H, and you also know what is the unit. If they want you to find the mole, the unit is mol. If they want you to find the heat or energy, the unit is joule. If they want you to find heat of something, heat of displacement, heat of neutralization, heat of anything, then is kilojoule per mole. Okay, so that is the unit. Yeah, all right, so that is the first part of today's lesson. So now let's continue. Okay, let's continue. So now we will start with heat of displacement. So now, like what I say, we have 4 calculation. Today we only focus on the first one. Today we only learn heat of displacement. Okay, all these 3 we will learn in subsequent lesson. Yeah, we will learn in next lessons. Okay, all right, so now let's start with heat of displacement. Okay, so what is heat of displacement? What is the definition? Definition means the meaning. What is the meaning, okay, for the heat of displacement? Okay, so heat of displacement is the heat change, okay, when 1 mole of metal is displaced from its salt solution by a more electropositive metal. Okay, so the definition sounds very long, very complicated, right? Actually, it's not really hard. Okay, it's not very hard. So don't memorize the whole thing without understanding. I repeat, don't memorize the whole thing here without understanding. Okay, so actually we learned about displacement before. So let's do a quick revision. We learned about displacement in your Form 5 Chapter 1. In Form 5 Chapter 1, we learned about the concept of displacement. Okay, so let's take about 5 to 10 minutes to do a very quick revision. What is displacement? Okay, so displacement, I call it as gangster bully concept. Okay, if you follow me since Form 5 Chapter 1, you should heard about the word gangster bully concept. Okay, what do we mean by gangster bully concept? Okay, gangster bully concept means the more powerful gangster, they can kick out the less powerful gangster, and they will rob its belonging. Okay, it will rob its belonging. Okay, all right, so you just imagine a concept like this. Okay, right, so you have A and you have B. Okay, so A is a more powerful gangster. Okay, B is a less powerful gangster. Okay, so this is A and this is B. Okay, just assume B have a boyfriend or girlfriend lah. Okay, so this is, okay, you can just assume lah, just assume this is the girlfriend of B. Okay, so what is the idea here? Okay, if A is more powerful than B, A will kick the B away. Okay, A will kick the B away. Okay, A will kick the B away. Okay, and after A kick the B away, okay, I kick it here lah. Okay, A kick the B away, and then A take the girlfriend of B. Okay, so that this concept is called displacement. Okay, the more powerful gangster kick out the less powerful one and then rob its belongings. Okay, so that is the concept of displacement. Okay, all right. So if we want to know who is the more powerful gangster, okay, we need to refer to electrochemical series. So how to know which one is a more powerful gangster? Okay, so we need to refer to electrochemical series. So same thing, we learn about electrochemical series in your Form 5 Chapter 1 as well. Yeah, so this is how we memorize the electrochemical series. Okay, kalau nak kahwin mesti ada zakar fantastic sebab papa hendak cucu anak. Yeah, alright. So this electrochemical series, okay, from here we can sort out the sequence. Okay, the K here stand for potassium, the N here stand for, okay, Na, sodium. Yeah, the K, the Ca, the kawin, calcium. Yeah, alright. M is magnesium, the A here it is aluminium. Okay, the Z here it is zinc. Fantastic, the F here is Fe. Okay, sebab the S here is Sn. Sn is tin, which is very rare to be tested in SPM. In SPM, they seldom ask you about the tin. Yeah, the P here is Pb. Pb is lead. Pb is lead. Yeah, all right. If you learn in BM, they call it plumber. If you learn in BM, they call it plumber. Yeah, all right. So P is Pb, the lead. Hendak, the H is hydrogen. Cucu, Cu. Cu is copper. Anak, A is Ag, silver. Okay, so make sure you know your ECS. Okay, so I always mention, if you're having a hard time to memorize, if you don't know how to memorize, take a piece of paper, copy this. Okay, kalau nak kahwin until the anak, and here you copy potassium blah 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 until Ag. Copy for few times. Yeah, once you copy for few times, it will help you to memorize this table. Yeah, so this table is very important. Yeah, this table is very important. Okay, if you don't know this table, you cannot do the concept of metal displacement already. Okay, so why we need to learn this ECS? ECS can tell us who is a more powerful gangster. So if you look at the ECS here, the higher the metal in the table, they are more powerful gangster. Okay, they are more powerful gangster. Example, magnesium is higher than copper. So you can say that magnesium is a more powerful gangster than copper. Okay, magnesium is a more powerful gangster than copper. Why? Magnesium is higher than copper in ECS. But in exam, you cannot write the word gangster, right? Because they don't know what do they means by gangster. In exam, you use this word. Okay, more powerful gangster means more electropositive. Okay, I repeat, more powerful gangster, we will use the word more electropositive in SPM. Okay, so if the magnesium is a more powerful gangster in SPM, you are right. Magnesium is more electropositive than copper. Yeah, magnesium is more electropositive than copper. That's it. Yeah, more electropositive means what? More powerful gangster. Okay, so I hope now you do a I hope now you can still remember this. This is nothing new, you know. I'm not teaching you a new concept. This is something that you have learned before. This is something that you had learned before. We just do a quick revision, yeah? So remember this. So displacement means more powerful gangster, they can kick out the less powerful one and rob their belongings. Okay? How to know who is more powerful gangster? We look at ECS. The higher in ECS, the more powerful gangster it is. In exam, cannot use the word gangster. You must use more electropositive. Okay? That's it. Okay, now look at this one. Okay, look at this example. Okay, so what is this? Okay, let me show you a simple example here. Okay, let me show you a simple example. Okay, so we have zinc. Okay, just for example, just assume that, you see, now we put a piece of zinc in a copper sulfate. So copper sulfate is a salt. Copper sulfate is a salt solution. Okay, we learn about salt in your Form 4 chapter 6. So you see, we put a zinc in a salt solution. The salt solution is called copper sulfate. So if you look at ECS, if you look at your ECS, you can see that zinc is here. Okay, zinc is here. Copper, it is here. As you can see, zinc is higher than copper in ECS, right? Everyone can see, right? Zinc is higher than copper in ECS. So which means what? Zinc is a more powerful gangster. Zinc is a more powerful gangster. So when zinc is more powerful gangster, what the zinc will do? So this will be a displacement. So the zinc will kick out the copper. So zinc will kick the copper out. Okay, zinc will kick the copper out and rob the girlfriend, the SO4. Yeah, zinc will take the girlfriend, SO4, and then zinc will kick the copper away. So you will get ZnSO4. Yeah, now the zinc take the SO4, and then now the copper don't have girlfriend anymore. You see, yeah? Now the copper is Cu. You see that? This is CuSO4 and this is zinc. So now zinc rob the girlfriend from the copper. Sorry, so I should do this. Okay, zinc rob the sulfate, okay, away. Then now the copper kick out. So copper now got nothing already. Yeah. So this concept called displacement. Yeah. This concept called displacement. Okay. So now we can try to analyze this together. Yeah. So you see. So I want you to know what is happening now. Okay. So look at this one. So zinc is more electropositive than copper. Yeah. Zinc is more electropositive than copper. Means what? Zinc is a more powerful gangster. So when zinc is more electropositive, what will happen? Zinc will displace the copper. Okay, displace means what? Kick out. The zinc will kick out the copper. Yeah, the zinc will kick the copper out. Okay, but we cannot use the word kick out. We must use the word displace. Zinc will displace the copper. Okay, where the zinc kick the copper out? Zinc kick the copper out from the copper sulfate salt solution. Okay, zinc will kick the copper out from the copper sulfate solution. So now I hope you understand what is displacement already. So now, okay, if you look back the definition, now it should make sense to you. Now it should make sense to you already. Okay, so what is heat of displacement? Heat of displacement is the heat change. Is the heat change. Okay, when 1 mole of metal is displaced. Okay, when we kick out 1 mole of metal, okay, where we kick the metal out? We kick the metal out from the salt solution. Okay, we kick the metal out from the salt solution. Okay, who kicked the metal out? More electropositive metal. Okay, so now I hope you can understand the concept. All right, when we put in a more electropositive metal, okay, into a salt solution, the more electropositive metal kick 1 mole of metal out from the salt solution. Okay, the more electropositive metal kick 1 mole of metal out from the salt solution, and in this process the heat is called heat of displacement. Okay, So that is how it works. Okay, so if you understand the concept, now you look at the definition, it's not too hard. Now if you look at the definition, now it is not too hard already. Okay, so let me repeat one more time. So if the question asks you what is heat of displacement, so your answer is this. Heat of displacement is the heat change, okay, when 1 mole of metal is displaced. Where 1 mole of metal is displaced, okay, where the metal we kick out, okay, where we kick out the metal from the salt solution. We kick the metal out from the salt solution. Okay, who kick the metal out? More electropositive metal. Okay, the more powerful gangster can go into the solution and kick 1 mole of metal out, okay, from the solution. And this is what we call heat of displacement. Do you need to memorize this definition? Yes, you need to memorize this definition. You need to memorize. Okay, this is a very common and very popular question in your SPM. In SPM, they love to ask about this. They love to ask you the definition for the heat. Yeah, all right. So now let's go on. Okay, so after we learn about the definition, okay, so now if we want to use the heat of displacement in this case, can or cannot? Can, right? So in this case, what is the heat of displacement? In this case, the heat of displacement is the heat change when, okay, so you see, do we know what is, you see, when we go for the heat of displacement, we must kick out 1 mole of metal, right? So in this case, what is the metal that we kick out? Okay, the metal we kick out is copper, right? We kick out the copper. So we write, okay, heat of displacement is the heat change when 1 mole of copper. Yeah, we kick out 1 mole of copper. Okay, okay, so we must kick the copper from where? You always kick the metal from the salt solution. Okay, so what is the salt solution here? So in this case, the solution, it is copper sulfate, right or not? We kick the copper out from the copper sulfate solution. So you see, okay, when 1 mole of copper is displaced, okay, from copper sulfate solution. Okay, so by who? Who kicked the copper out? Okay, who kick out the copper? Okay, you kick out by more electropositive metal. Yeah, by the more powerful gangster. So who is the gangster here? So in this case, the zinc is more powerful gangster. So the zinc will kick the copper away. So you see, you will kick the copper from the copper sulfate by the zinc. Okay, so I hope you can understand what is the heat of displacement for this equation. Yeah, so for this equation, heat of displacement is the heat change when 1 mole of copper, when the copper is kicked out, okay, where the copper kick out from copper sulfate solution. Okay, it's kicked out from copper sulfate solution. Who kicked the copper out? Zinc. Yeah, so that is what we need to know. Okay, this is what we need to know. All right, it's not very hard. Most importantly is understand the concept. Yeah, understand the concept behind. Okay, then you will be fine. All right, so now, okay, I have covered the theory. So now I will show you the experiment. What is the experiment for the heat of displacement? So when you want to carry out the experiment for the heat of displacement, this is what you do. So first of all, you must take a cup. So this cup is a polystyrene cup, or we call it a plastic cup. It's a polystyrene cup or it's a plastic cup. Many students ask, sir, can we use a beaker? Cannot. I'll tell you why in a short while. Can we use other other container like zinc container? Cannot. All right. You must only use polystyrene or plastic container. Yeah. So why? We will learn in a short while. Okay. So you can see inside the cup we put the copper sulfate. So copper sulfate is the salt solution. Is the salt solution. Then here we put a zinc powder. Yeah, we put the zinc powder. All right. So you can see zinc is a more powerful gangster. Can go in to kick the copper out from the salt solution. Yeah, so we are doing displacement concept. And the most important thing here is you will see thermometer. Okay, all the experiment for heat. Okay, all the experiment that involve heat. Okay, all the experiment that involve heat. For example, heat of displacement, heat of combustion, heat of neutralization, heat of precipitation. All the experiment that involve heat, you must measure temperature. Okay, you must measure the temperature, okay, for all the experiment that involve the heat. That's why we need a thermometer here. So the thermometer is used to measure the heat here. Okay, so make sure you know this diagram. So this diagram is very simple. So to do metal displacement, we need metal. Okay, so we put some metal powder, and then we must put a salt solution. So we use a plastic cup to put your salt solution. Yeah, so this is salt solution, and this is the more powerful gangster, the metal. Yeah, and then this experiment, we want to measure the temperature. We put a thermometer. Yeah, so this is the diagram for the experiment in heat of displacement. Okay, so here you must understand these four concepts. You must understand these four concepts. Okay, why we use zinc powder? Why we use zinc in powder form? Why not you put one piece of zinc? Okay, one whole piece of zinc. Or why not you put like this? Okay, a bigger granule. This is a bigger granule of the zinc. Why not? Why you don't use a bigger piece of zinc? Why the zinc you have to use some powder? Okay, we learn this in your Form 4 Chapter 7. Okay, Form 4 Chapter 7. Yeah, we know that when we use powder, the reaction is very fast. When we use powder, the reaction is very fast. So we use the zinc powder to speed up the reaction. We use the zinc powder because we want to speed up the reaction. Yeah, that's it. So the second one, this is a very popular SPM question. They will always ask you why we use a polystyrene cup or plastic cup. Why? Why we want to use the polystyrene cup or the plastic cup? Okay, so this one is very important. We use the polystyrene or plastic cup because we want to reduce or minimize the heat loss to surrounding. Yeah, we want all the heat stay inside the solution. We want all the heat stay in the solution. So we don't want the heat to go out from the cup. Yeah, we don't want the heat to run away from the cup. Yeah, so the heat that run away from the cup, we call it heat loss to the surrounding. Okay, so the reason why we use the polystyrene cup or plastic cup is because we don't want the heat to run away to the surrounding. Yeah, so that's it. Okay, just like you see. Okay, why when we put some, okay, why let's say when you go over to buy some coffee in some of the coffee shop, why they use a plastic cup to put the hot coffee? Okay, why they put hot coffee in a plastic cup? Because they don't want the coffee, the heat to go out from the hot coffee. Because if the heat go out from the hot coffee, the coffee will become cold very fast. Okay, so when we order the hot coffee, of course we want to drink it while hot. Okay, we want to make sure it's hot. Okay, so if we use the plastic cup is because we want to minimize the heat loss to surrounding. So when we can reduce the heat loss, so now the coffee they can stay hot for a longer time. Yeah, they can stay hot for a longer time. Okay, so that's it, right? So that is the basic idea. Okay, so this is why we don't use a glass cup. Okay, if you use a glass, imagine this. If let's say you put a hot water in a glass cup and you put the hot water in the plastic cup. Okay, this is hot water in the plastic cup. You see, okay, let's say initially the hot water is 80 degrees Celsius. Okay, so let's say after 30 minutes, you will realize that the glass cup, the temperature is very low now. From 80 maybe become 30. Okay, but if you look at plastic cup, because the heat cannot run away, the heat hardly run away. After 30 minutes, you still get very hot, maybe still have 60 degrees Celsius. Okay, so I hope you can understand what is happening here. Okay, when we use the plastic or polystyrene, they can reduce the heat loss to the surrounding. Yeah, they can reduce the heat loss to surrounding. So make sure you use the word reduce or you use the word minimize. Cannot use the word prevent. You cannot use the word prevent. You cannot say polystyrene cup or plastic cup can prevent heat loss to surrounding. Cannot. Prevent means what? Prevent means the heat cannot run away totally. Okay, so that is wrong. If you use a plastic cup, still got some heat will run away one. Still got some heat will run away one. Okay, but very little lah, very little. Okay, so don't use the word prevent. Okay, there is no way we can prevent the heat loss. We cannot totally stop the heat to run away. Cannot. We only can make it lesser. Okay, we only can make it lesser, or we can minimize it. Okay, so please make sure you use the proper word, reduce or minimize. Okay, all right, next one. When we do this experiment, we must make sure the zinc powder and the copper sulfate solution here must mix quickly. Okay, you must put the powder into the solution as fast as possible. Okay, you must put the powder into the solution as fast as possible. Okay, so you mix the zinc powder and you mix the copper sulfate solution quickly. Okay, why we must mix very quickly? Because if we mix quickly, okay, the heat loss to surrounding is lesser. Okay, if we mix, okay, quickly, the heat loss, okay, is actually lesser. Okay, imagine this. Imagine, let's say, all right, here we have 1 kilogram of powder. If you put 1 kilogram of powder one shot, okay, at one shot, you put in 1 kilogram of powder within, let's say, 10 seconds. Okay? In 10 seconds, you add all the powder in. Compared to this 1 kilogram of powder, okay, you go to put little by little. Okay, you go to put a little bit first, then a little bit more, then a little bit more, a little bit more. And this process, let's say it takes 30 minutes. Okay, let's say now you use 30 minutes, only you add all the powder in. So what happened? So in this 30 minutes, all the heat already run away. All the heat already run away. We don't want, right? Remember, in this chapter, we don't want the heat to run away. When we do the experiment, we want the heat to stay inside here. Okay, we want the heat to stay inside. We don't want the heat to run away from the cup. Okay, this is the main focus in the experiment. For all the experiment that involve the heat, we don't want the heat to run away. So I want you to understand that. Okay, so if we take a long time to mix them together, all the heat already run away. So we don't want. So we want to mix very quickly. Yeah, we want to mix very quickly. Yeah, so because if we mix very fast, so very little heat will run away one. Yeah, so that's it. Okay, so next one. Throughout this experiment, in this entire experiment, we always need to stir the mixture. Okay, we stir the mixture using the thermometer. We will use the thermometer to stir the mixture. Okay, like this. Okay, in this whole experiment, we will use this thermometer to stir the solution. Why you want to use the thermometer to stir the solution? We want to ensure that the temperature is even. Okay, we want to make sure the temperature is even. Even means what? Balance. Okay, because if you don't stir, maybe this part is a little bit hot. Maybe this part 28 degrees Celsius. This part maybe 18 degrees Celsius only. Maybe this part 20 degrees Celsius. Okay, so it's not even. If you put a thermometer inside and you kacau, okay, you just stir it, then what happened? The whole solution also same temperature. So here 28, here also 28, here also 28, here also 28, here also 28, okay? So if you stir the solution, so the temperature will be very even, yeah? The temperature will be balanced, will be even, yeah? Yep, that is what you need to know, okay? So these are 4 important steps that we must know, okay? So let me repeat one more time, huh? Okay, why we add in the zinc in powder form? Why we use powder? Because powder, the reaction is faster, huh? So we add in the powder to speed up the reaction, okay? All right, so next one, when we mix, we must mix quickly. We must mix quickly. So why we must mix quickly? So that we can minimize the heat loss to surrounding, huh? So we can minimize the heat loss to surrounding. So don't have so many heat that run away from experiment, okay? So same thing, why we use a polystyrene cup of plastic? Because polystyrene and plastic, they can minimize the heat loss, they can minimize the heat loss to the surrounding, okay? So when we use plastic, when we use polystyrene, not much heat can run away to the surrounding, yeah? So last one, why we use the thermometer to stir the solution? We want to make sure the temperature is balanced, the temperature is even, yeah? So this is why we need to know these 4 concepts, okay? All right, so now we are all done with the theory already, yeah? We are all done with the theory. Now I will teach you some calculation, okay? I'll teach you calculation. We will do 5 example, yeah? We have total 5 example here. I will show you step by step how to do the calculation, okay? After these 5 example, then I will show you SPM format question, so we have 2 more SPM format question right after this, okay? So but now we will start with the 5 basic calculation question first, okay? So let's look at it. So I'll teach you step by step what you should do. So watch up and then try to get the idea, yeah? Okay, so let's start with the sample calculation question number 1. So let's do it together. Okay, so for this question, the question say Ame carry out a displacement reaction, okay, by mixing excess magnesium powder into 50 cm cube 0.2 mole per dm cube iron 2 sulfate solution. The temperature of the solution increases from 34 to 44 degree Celsius, okay? So now the question asks you to calculate the heat change in this reaction. So what you should do? So remember, when the question asks you to find heat change, what it is? If they want you to find heat change is Q, right? Okay, we learned earlier today, yeah? We learned earlier today. If the question asks for heat change, they want us to find Q. What is the formula to find Q? Q equal to MC theta. Q equal to MC theta, okay? So let's try to do this, okay? So the M here is referred to the mass of solution. The M here is mass of solution. So in this chapter, we only focus on the mass of solution. We don't want the mass of solid. We don't want the mass of gas. I repeat, in this chapter, thermochemistry, in this chapter, Form 5, Chapter 3, all the calculation, the mass, we only focus on mass of solution. So what is the mass of solution? I say early on today, mass of solution is exactly same as the volume of the solution, okay? So do we have a solution here? Yes. We have iron 2 sulfate solution. What is the volume? 50 cm cube. So when the volume is 50 cm cube, the mass is 50 gram. So 50, okay? So remember, volume same as mass, okay, in this chapter. Okay, next one is the C. C is heat capacity. C is heat capacity. Heat capacity, the value will be provided. They will give us the heat capacity. So you see the question? The question tells us the specific heat capacity is 4.2. So we use the 4.2 given by the question, okay? So the next one is theta. Theta is temperature change. So to find temperature change, we take the high temperature minus the low temperature. Okay, just take the high temperature minus the low temperature. Okay, so just key in this whole thing into your calculator. Yeah, when you key into calculator, you will get 2100. Okay, you will get 2100. Okay, so don't forget the unit. So in this chapter, after the calculation, please don't forget about the proper unit. Okay, so what is the unit? Since the question asks you for heat, heat is a type of energy. Okay, heat is a type of energy. Unit for energy, it is joules. Okay, unit for energy, it's joule. So the final answer is 2100 joule. That's it. Okay, so that's all for the first question. Okay, I hope you can understand step by step how I solve the question. Okay, all right, so next one. So let's go for the next question. So for the next question, all right, so you see the question say what? By mixing copper powder into 100 cm cube 0.5 mole per dm cube of silver nitrate solution, the temperature of the reaction mixture change from 29 to 33. Find the heat of reaction. Okay, so what they want, the question say heat of reaction. So when we see heat of something, okay, we are looking for delta H. So when the question wants us to find heat of something, we want to find delta H. So what is the formula for us to calculate delta H? Okay, so same thing we learned about the formula just now. Delta H equal to plus minus Q divided by N. Plus minus Q over N. Okay, so let's try to do the calculation now. Okay, so the first thing we need to find is the Q. Okay, we need to find the Q first. Okay, we need to find the Q first. Okay, so let's find the Q first. So we know Q equal to MC theta, right? Q equal to MC theta. Okay, so the M is the mass. Okay, mass of what? Mass of solution. So in this chapter, all the mass is referred to the mass of solution. So mass of solution is same as the volume. Remember in this chapter, the mass of the solution is exactly same as the volume of the solution. So what is the volume of the solution? So the solution, the volume, it is here. It is 100. So 100 is the volume. Okay, so C is heat capacity. So heat capacity is given here, which is 4.2. Okay, so they give us the value for the C. So theta is temperature change. Temperature change is what? Temperature change 29 become 33. So we take higher temperature minus lower temperature. So we take 33 minus with 29. Okay, so now you just need to key in the whole thing into your calculator. Yeah, just key in this whole calculation into your calculator. So you will get 1680. Okay, not to forget about the unit. Don't forget about the unit. So Q, the unit is joule. Q is joule. Okay, we are not done yet. We are not done yet. Okay, so now we already know the Q. Okay, so we put the formula into the Q here. Okay, we can put the formula into here first. So we copy the formula again. Okay, so now let me move a bit upwards first. Okay, all right, so now delta H, okay, we substitute delta H equal to, okay, plus minus. Okay, we should use plus or we should use minus. Okay, to use plus or minus, we must know the reaction is endothermic or exothermic. I repeat, if you want to use plus or minus, you need to know the reaction is endothermic or exothermic. So in exam, normally they won't tell you. They are not so kind to tell you, oh, this reaction is endo, this reaction is exo. They won't tell you. Okay, you have to use a concept that we learned in lesson number 1. Okay, how to know is endo or exo? We can look at temperature. temperature from 29 to become 33. Temperature increase. Okay. So we learned before, when temperature increase, it is exothermic. Okay. If you already forgotten, if you are blur, please revise back your lesson number 1. Lesson number 1, we learned that endothermic, D stand for decrease, temperature decrease. Exothermic, temperature increase. Okay. So that's what we learned in lesson number 1. So in this question, since the temperature increases, so it's exothermic. So exothermic, we put negative. We put negative here. So the Q we know already. So the Q we know, we copied it. Q is 1680 joule. So now we need to divide, and the small capital N. Okay, small capital N stand for what? Small capital N stand for mole. Okay, what is the mole that we are looking for? What is the mole that we want? So remember, we are looking for heat of what? Okay, this is a displacement reaction, right? This is a displacement. Copper want to go and kick the silver, right? So this is a displacement reaction. So for displacement reaction, displacement, what is the most important thing? You want to kick the metal out, right? You want to kick a metal out. Okay, so this mole is referred to the mole of the metal that is displaced. This is referred to the mole of the metal that we kick out. This mole is the mole of the metal that we kick out. Okay, so how to know the mole of the metal that we kick out? Okay, so look at the tips here. Okay, so remember, if you want to calculate heat of displacement, we need to find the mole of the metal that we displace first. So how to find the mole of the metal we kick out? So in this question, do they mention the metal that you kick out? Do they tell you which metal is kicked out? Do they tell you which metal is kicked out? No, right? They didn't say. They only tell you copper powder mixed with silver nitrate. They didn't tell you which metal is kicked out. So what you should do, you should write a chemical equation. You should write a chemical equation. So we have copper powder. So copper, the formula is Cu. Okay, react with what? We have silver nitrate solution. So silver nitrate solution, the formula is AgNO3. How to get this formula? You learn in your Form 4 Chapter 3. So if you have silver nitrate, you can get the formula by knowing the charge. Silver, the formula is Ag plus. Nitrate is NO3 negative 1. So if you look at the charge, this is positive 1. This is negative 1. When the charge is the same, you cut it out and you join together. So you get AgNO3. Okay. So this is how we predict the formula for the silver nitrate without memorizing. So now what it is, this is a gangster bully concept, right? Copper is a metal, silver is a metal. So if you look at your ECS, if you look at your electrochemical series, this is copper and this is silver. Copper is higher than silver in the ECS. Copper is higher than silver in ECS. So copper is the more powerful gangster. So when copper is the more powerful gangster, copper will kick the silver out. So we kick the silver out. So silver is here. So now the copper will take the nitrate. Copper now will take away the nitrate. Okay. So you don't just take Cu and NO3 join together like this. Don't do that. Okay. So we know the copper will take the nitrate away to become copper nitrate. So we need to predict the formula for the copper nitrate, and we need to predict the formula for copper nitrate. Okay, so how to predict the formula? Copper is Cu2 plus, nitrate is NO3 minus. So the charge is different. So we learn in Form 4 Chapter 3, when the charge is different, we do a cross method. So when we do a cross method, we will get Cu NO3 too. Okay, I hope you know what am I doing. Okay, so now we already get this equation. And after that, don't forget, every time when you write an equation, you must always balance it. So we can put a 2 here and put a 2 here to balance. Okay, so now we already write this equation. Okay, why we want to write this equation? We want to write this equation because we want to find the mole of metal that is displaced. So which metal is displaced? Which metal we kick out, everyone? Which metal we kick out? This one, right? Silver, right? Silver is the metal that we kick out. So we need to find the mole. How many mole of the silver that we kick out? Okay, so what is the information that we have? So we are given the information for silver nitrate. You see, we are given silver nitrate solution. Silver nitrate solution, we are given 100 cm cube and 0.5 mole per dm cube. So you see, I copied it. 100 cm cube and 0.5 mole per dm cube. Okay, so what are the information they give us here? Okay, everyone, what are the information they give us? So 100 cm cube is volume, is a V. 0.5 mole per dm cube. Okay, we learned in Form 4 chapter 6. Anything ended with mole per dm cube, it is molarity. Molarity, the symbol is M. Okay, all right. Okay, so now if we want to find the mole of the silver, so we are not given any information about the silver, right? We are not given any information about silver. So we have to start from here because we only know this one. Okay, we only know this one. So how to find the mole? Okay, so silver nitrate is a solution. Silver nitrate is a solution. Okay, so for solution, to find the mole, we use the N equal to mv over 1000. Okay, so this is the formula for us to find the mole of solution. So the solution, the concentration is 0.5, volume is 100, divide by 1000. Okay, so by doing this calculation, we get 0.05 mole. Okay, so now we get the mole. Okay, but the mole that we get is refer to the silver nitrate. We get the mole of silver nitrate, but we want the mole of the metal that is kicked out. We want the mole for the metal that we kick out, which is the silver here. So when we know the mole of this, how to find the mole of this one? Okay, we can do a ratio. Okay, we can refer to the ratio. Okay, so when we do a ratio calculation, okay, the silver nitrate, okay, we look at here the ratio calculation. Okay, so the silver nitrate and also the silver. Okay, so ratio, we can look at the number at the front. So silver nitrate, the number in front is 2. Silver, the number in front is 2 as well. 2 to 2. So 2 to 2 means what? 2 to 2 means they are the same. Yeah, 2 to 2 means they are the same. So from here, we can find the mole of the silver that we kick out. Yeah, so the mole of the silver we kick out is the same as this, 0.05. So now we found the mole already. So we can put the mole into this formula. So this formula, we copied it. Okay, we can just put the mole inside again. Yeah, just put the mole at here. So when we put the mole, 0.05. Okay, the unit is mol. Okay, so now this whole thing we can key into our calculator. We have 1680 divided by 0.05. Okay, so we will get 33,600. Don't forget the sign, it is negative. And here the unit is what? This is joule, and then this is mole. Okay, joule per mole. So we are not done yet, because we, as what I say, the unit is important. Delta H, the unit is kilojoule per mole. Delta H, the unit is kilojoule per mole. So now we have joule per mole. How to change joule to kilojoule? We move 3 steps to the right. Okay, mathematics. We move 3 steps to the right. So we will get, okay, negative 33.6 kilojoule per mole. So that is how we do the calculation. This is how we solve it. This is how we do the calculation. Okay, So it's not very hard, but you must do it step by step. You can see, okay, it looks like it has a long calculation, but if you do step by step, it's not very complicated. Okay, so the idea is this: when the question asks you to find heat of something, so you are looking for delta H. To find delta H, this is the formula. So we need to find the Q using the MC theta. Then after that, we need to find the N. The N is the mole. For heat of displacement, we want to find the mole of the metal that we kick out. We want to find the mole of the metal we kick out. So how to find the mole of metal we kick out? We write a chemical equation. So when we write a chemical equation, we find the mole for the silver nitrate solution first. We find the mole for silver nitrate solution first. Why? Because we are only given this information. We only given this information, so we need to start the calculation from here. So once you found the mole for the silver nitrate, you do ratio to find the mole of the silver. Yeah. So now we know already the mole of the metal that we kick out, which is the silver, which is 0.05. So you put into the formula again. So after you calculate, the unit is joule per mole. So but we want kilojoule per mole. Okay, so we divide by 1000 because kilo is 1000. Yeah, so that is how we do the calculation step by step. Okay, so let's try another one more question. So this is your sample calculation for your question number 3. Yeah, so for this question, they are giving us a energy level diagram. So they gave us energy level diagram for the heat of displacement. So we learned about energy level diagram in your lesson number 1. So the question say, if 3.2 grams of copper is displaced, okay, we kick out. Displaced means we kick out. So we kick out 3.2 grams of copper. Find the heat released in this reaction. Yeah. So this is a very good question. This is a very, very good question. Yeah. So when they ask us to find heat release, what we want? So heat release supposed to be Q, right? If they ask for heat, it should be Q. Heat off is delta H. To find Q by right, we need MC theta. True or not? Okay. If you want to find Q, the formula supposed to be MC theta. M is the mass of the solution. So do you given the mass of the solution? So mass of the solution is equal to the volume. So do you given the volume? Nope, you are not given the volume. So some student will say, sir, they give us 3.2 gram here. This is no. This 3.2 gram is copper. Remember I say what? The mass is referred to the mass of solution. I want the mass of solution, not the mass of solid. Copper is solid. I don't want the mass of solid. I want the mass of solution. So we don't have the mass of solution. C is heat capacity. Do they give us the heat capacity? Nope. They are not giving us the heat capacity. Theta. Theta is the temperature change. Do they give us temperature? Nope, they don't. So you see, we don't have M, we don't have C, we don't have theta. We don't have all the information. So when we don't have all the information means what? This formula cannot be used. Okay, this formula cannot be used. So then some will say, sir, if this formula cannot be used means cannot do calculation, is it? No. So in this chapter, when you come to the calculation of heat, there are two important formula. The first one is Q equal to MC theta. The second formula is delta H equal to plus minus Q over N. Remember, these are the two super important formula in this chapter. Yeah. So if this formula tak boleh pakai, cannot use, so we will try to do this formula. Okay, we will try to use this formula. Okay, so let's try the second formula. Delta H equal to plus minus Q over N. Yeah, so now we will fill in the blanks. We will fill in the blanks to do the calculation. So do we know the delta H? Yes, the delta H is given. We are given the delta H. What it is? The delta H is negative 210. So we are given, so it's negative 210. But here is kilojoule per mole. Kilojoule, kilo means what? 1000. So you must multiply by 1000. Alright? Right? Because this one is negative 210 kilojoule per mole. So kilo, you must multiply by 1000 for the calculation. Yeah? So, okay, so equal, so copy back. Okay, plus minus depends on endo or exo. Plus minus depend on endo or exo. Do we know the reaction is endo or exo? Do we know? I will say yes. Because you can see the delta H is negative. When they give you the delta H is negative, so you know that this is exo. When they give you delta H is negative, you know it's exo. So I know it is exo, I put negative. So Q is what? Okay, Q is what we want to find, right? We want to find the Q. We want to find the heat. So Q is what we want to find. So just copy it. So divide by N. So N, what is the N here? Okay, N is the mole. N is mole. So what is the mole that we're supposed to find? Remember, we are doing the calculation for heat of displacement. In heat of displacement, what is the most important thing? The most important thing is we want to kick the metal out, right? We want to kick the metal out from the solution. So the mole is referred to the mole of the metal that is displaced. We want to find the mole of the metal that we kick out. Okay. So do we know what is the metal we kick out? I will say yes, because the question tells us 3.2 grams of copper is displaced. So we know that we kick the copper out. So now we know the copper is kicked out and the copper is 3.2 grams. So we are given 3.2 grams of copper. Okay, so can we change the mass of the copper to mole? Okay, we are given the mass of the copper. Can we change to mole? Yes, right? Mass and mole. Okay, mass convert to mole. We learned this in your Form 4 Chapter 3. To change the mass to mole, we use RAM. Okay, to change anything to mole, we use divide. So this is something you learn in your Form 4 Chapter 3. So what is the mass? 3.2. So what is the RAM? So the RAM of copper, okay, they should give you here. So let me give you this. RAM of copper supposed to be 64. Okay, I forget to write just now. So sorry for that. Yeah, I forgot to write. Okay, so should be 64. So 3.2 divided by 64, the answer is 0.05 mole. Okay, so now we already know the mole. Okay, so which we can put it here already. Yeah, so we just copy this equation. Okay, so let me copy this equation. Okay, and I'm going to put it here. All right, so the mole here we know already it is 0.05. Okay, so from here you can do your mathematic calculation. So negative and negative you can cancel out. Okay, then you bring the 0.05 here to multiply. Yeah, so you key in this whole thing into your calculator. Yeah, you key in this whole thing into your calculator. Okay, all right, so you're gonna get, okay, the answer. The final answer is, okay, let me double check to make sure everything is correct first. Okay, 210 is good. Okay, all right, so if you key in the calculator, so your Q, the final answer is 10,500. Yeah, 10,500. And make sure you know the unit. Make sure you know the unit. Yeah, so the final unit, okay, the final unit, Q is what? Q is heat. Q is heat. So heat is energy. Energy, the unit is joule. So that is how you do the calculation. Yeah, all right. So now, okay, so you see, it's all about these two formula only. Okay, so the basic idea I just want you to know is always these two formula. Q equal to mc theta, delta H is plus minus Q over N. If this formula cannot use, then it must be this. Okay, If this formula cannot use, then it must be this. Okay, these are the two very important formula that we need to know. Okay, it's always these two formula only. Yeah, all right. So now let's go for the next one. Okay, so this is question number 4. This is question number 4. So the question say, when the metal X is displaced from the 200 cm cube of X sulfate solution, 8,232 joule of energy is released. Determine the change in temperature. Okay, so what we want, change in temperature. So change in temperature is what? Change in temperature is theta. Okay, we want to find change in temperature. Yeah, so change in temperature is referring to theta. Okay, so remember, we always play with two formula. One is Q equal to mc theta. Another one is delta H equal to plus minus Q over N. These are the two most important formula. So which formula can help us to find theta? So this one, only the first formula got theta, right? So let's copy it. Q equal to mc theta. Okay, Q equal to mc theta. Okay, so now to find this, so we need to fill in the blanks. We need to fill in the blanks. Do we know the Q? Q is heat, okay, or energy. Is heat or is energy? Do we given the heat or energy? I would say yes. We are given the energy to be 8,232. So 8,232 we are given, okay, equal to M. M is mass. So in this chapter, the mass is referred to the mass of solution. In this chapter, all the mass is referred to solution. And I said just now, mass of solution is same as the volume. Mass of the solution same as the volume of the solution. So now we know the solution. The volume is 200. So we put 200 here. C is heat capacity. So heat capacity is given already. The heat capacity, the value is always given. So we don't need to memorize. Okay. So just put the value in 4.2. Okay, 4.2. Then the last one is the theta. Theta, we don't know. Just copy it. So do your mathematics. So when you do your calculation, okay, if you do your calculation using your calculator, theta, so you should able to find that theta, the final answer is 9.8. Okay, and don't forget about the unit. Please don't forget about the unit. Okay, what is the unit here? Okay, they are looking for temperature change. So temperature, the unit is degree Celsius. Okay, the unit for temperature, it is degree Celsius. Okay, that's it. So this is how we do the calculation. Yeah. Okay, so it's okay. So that's why I say you must know what the question want. Okay, so the main formula is always Q equal to mc theta, delta H equal to plus minus Q over N. These two formula super important. Okay, so let's go for the next one. Okay, so this will be the last question. Okay, last sample calculation. Okay, so for this question, you are given the energy level diagram. You see the staircase, right? Energy level diagram. So they ask you to calculate the highest temperature when zinc powder is added to 200 cm cube, 0.5 mole per dm cube, copper sulfate solution. Yeah, so you are also given a picture like this. So how to do it? Okay, first of all, the question asks for highest temperature. So temperature, so we need to go for theta. Okay, we need to find the theta first. Okay, we need to find theta. So how to find theta? Okay, we have two formula in this chapter. Okay, so the first formula is Q equal to mc theta. The second formula is delta H equal to plus minus Q over N. Yeah. So this formula has theta. So we will try to use this formula first. Okay, fill in the blanks. Okay, so fill in the blanks. Do we know? So now we want to find theta, right? So do we given Q? Q is the heat. So for this question, do they give us the heat? No, right? They didn't give us the heat, right? So this is delta H. So they didn't give us the Q. If you read the whole sentence, they don't give us the Q. Yeah. So the Q they not given us. Okay. So M is the so now we need to find the Q first. We need to find the Q first because we don't know the Q, we don't know the theta, cannot solve one. Okay, if you have two unknown mathematics, you cannot solve one. So we need to find the Q first. So how to find Q? We will use another formula. Yeah, because this formula we already sangkut, right? We already sangkut here. We already stuck here because this formula we don't know the Q, we don't know the theta. So we already sangkut, so cannot continue anymore. So we need to use another formula. This formula also can help us to find Q, right? This formula also got Q. So let's try to do this formula first. So for this formula, fill in the blanks. Do we know delta H? Do we know the delta H? I would say yes. The delta H we know. The delta H is here, negative 217. Okay, the delta H it is 217, negative. So copied it, negative 217. But watch out. The 270 is kilojoule per mole, is kilo. So kilo means it must multiply by 1000. Okay, it must multiply by 1000. Okay, so equal to, okay, plus minus depends on exo or endo. Depends on exo or endo. This reaction, the delta H is negative. So negative is exo. So when we see negative is exo. So exo we put negative here. Okay, we put negative here. Alright. So the Q, we don't know. Just copied it. So now we left N. So N is the mole. Okay, what is the mole that we are looking for? Okay, what is the mole that we are looking for? So this is heat of displacement. Heat of displacement, we want to find how many mole of the metal that we kick out. How many mole of metal, okay, that is displaced. Okay, how many mole of the metal that is displaced, okay, that we kick out. Okay, so how to find the mole of the metal that is kicked out? Okay, so we copy this chemical equation first. Okay, we just copy this chemical equation. Okay, we have zinc plus copper sulfate to become zinc sulfate and copper. Okay, so from this equation, what we want to find? We want to find the mole of the metal that is kicked out. So which metal is kicked out? Copper. So we want to find the mole of this copper. Okay, so what is the information it gives us? The question gives us volume and concentration for the copper sulfate solution. So for the copper sulfate solution, we are given the volume, which is 200, and then we have the concentration of 0.5. Okay, so this is what we have, and this is what we want. So what should we do? So we should find the mole for copper sulfate first. Okay, when we given M and V, we know it is solution. I repeat, when you see a big capital M and big capital V, you know it is a solution. So can we find the mole of solution? Yes, right? You can find the mole of copper sulfate solution by using the formula N equal to mv over 1000. This is the formula to find the mole of solution. So the concentration is 0.5, the volume is 200 divided by 1000. Okay, so if you do the calculation, you will get 0.1 mole. Okay, so now we already get the mole for the solution. Okay, we already get the mole for the solution. Yeah, so after we get the mole for the solution, okay, so the next one, we want to find the mole of the metal that is kicked out. So the metal which is kicked out is copper. So we need to use the ratio. Okay, so we use the ratio, okay, between this copper sulfate and copper. Okay, so we just write this. So copper sulfate and copper. So what is the ratio? Ratio, we look at the number in front. Copper sulfate number in front is 1. Copper, the number in front is 1. So the ratio is 1 to 1. So 1 to 1 means they are the same. They are the same. So from here we can find the mole of the copper, which is the same as this, 0.1 mole. Okay, so now we already found the mole of copper, so we can put into this formula already. Yeah, this formula. Okay, let me copy this. Okay, and then we put the mole back into this formula. Okay, okay, so we just change the mole here with 0.1. Okay, so from here we just key into the calculator. Okay, we just key in to the calculator, so we will get the Q. So the Q, it is 21,700 Q. Okay, so the unit for Q is joule. Alright, so now we get the Q already, but this is not the final answer. So remember, we want to find the temperature. So temperature, we need to use Q equal to mc theta. So now we know the Q already. Yeah, so now just now we don't know this formula. Now we already know this. Okay, so now we already know the Q. So now I copy this equation. Okay, I copy this equation. I just put it here. So now the Q we know already. Yeah, so the Q, it is 21,700 equal to the M. So M is the mass. Mass is referred to mass of solution. So in this chapter, all the mass is referred to solution. What is the mass of solution? Mass of solution same as the volume. So the solution is 200. The solution is 200. So we just take the 200 here. Okay. So the C is heat capacity. So the C is the heat capacity. Heat capacity, the value should be given, which is here. Alright, sorry, I forget to put in. Okay, so I should put in the heat capacity, which is 4.2. Okay, and then here we have theta. Okay, alright. So from here we can just do the mathematics. We just do mathematics to calculate the value here. Okay, so if you calculate the theta is equal to 25.8, yeah, 25.8 degrees Celsius, and this is not the final answer, because this 25.8 is theta. Theta is what? Theta is temperature change. Is temperature change. So they want us to find highest temperature. Highest temperature. So how to find the highest temperature? Okay, so the initial temperature is given here, 33.3. So the initial temperature is 33.3. So we know that. Okay, the initial temperature, it is 33.3. So now we know temperature change is 25.8. So temperature change can be increased or decreased. Temperature change, it can be increased or decreased, right? True or not? Okay, it can be increased or decreased. How to know you should increase the temperature or decrease the temperature? So the question asking for highest temperature. Highest. So temperature need to go higher. Higher need to increase. So we will increase the temperature for 25.8. Yeah, so the temperature need to increase by 25.8. Okay, so now we can find the highest temperature already. Okay, so highest temperature is 33.3, then increase by 25.8. Yep, that's it. Okay, that is how it works. Okay, so if we add everything together, 33.3 plus 25.8, yeah, so the final answer is 59.1 degrees Celsius. So that is the highest temperature. Okay, so again, the calculation looks very complicated, but not really actually. Why? Because at the end of the day, it's still about these two important formula. Q equal to mc theta, delta H equal to plus minus Q over N. Yeah, we just play around with these two formula only. Yeah, the main concern is always these two. Yeah, these are the two super important formula that we will play around. Yeah, so it's always between these ones. So you see, just now, like what I said, the question wants us to find highest temperature. Temperature must be related with theta. So I know Q equal to MC theta. So I want to find theta. But for this formula, I don't know the Q. So since I don't know the Q, I need to find the Q. I use another formula, plus minus Q over N. I use this formula to find the Q. To find the Q, I need to find the delta H. Delta H is given. So I need to find the mole. The mole is not given. So that's why I do the calculation. I was given the volume and the concentration for copper sulfate. So I use N equal to MV1000 to calculate the mole of the copper sulfate. So once I know the mole of copper sulfate, I can use ratio to find the mole of copper that I kick out, yeah? Alright, so once I know the mole of copper that I kick out, I can put it here. So when I have this, I can find the Q. So once I found the Q, I put the Q into the formula here, okay? So now I have the Q, M is the mass is given, C is heat capacity is given. So from here we can find the theta already. So once we have theta, so now we know the temperature change, okay? So now we want to find the highest temperature. So to find the highest temperature, we just need to use the initial temperature increase by the theta, okay, increase by the 25.8 degrees Celsius. Then we were able to find the highest temperature already. So I hope all the tutorial that all the examples that I show you just now, these 5 example, you fully understand what it is, okay? Because when you fully understand these 5 example, you should able to do all the calculation. You should able to do all the calculation, okay, for the heat of displacement. Yeah, it's not very hard. Most importantly, you follow the step. Yeah, you follow the step by step, how it works. Okay, all right. So that's it. So now I will show you a past year question. Okay, I'll show you some example for the real SPM past year question. This is how they ask the question for heat of displacement in the real exam. It combine everything that we learned so far. Yeah, it combine everything we learned in lesson number 1 and lesson number 2. Okay, so let us try to do it together. Yeah, let us try to do it together. Lesson number 1, lesson number 2. Okay, so I want you to see the way they ask the question, the format they ask the question. So you see, yeah, so you are given a picture. So in this picture you have zinc powder, we have polystyrene cup, we have copper sulfate salt solution. Yeah, all right, so this one should be a displacement because the question say heat of displacement. Okay, so let's start with the question. Okay, so the first part, okay, so and then they give us the result. This is the initial temperature and this is the highest temperature. Okay, so the first question is asking us what is the type of reaction that occur based on temperature change. So if they ask you about temperature change and the reaction, it must be endothermic or exothermic. Okay, if you want to describe the reaction by using temperature change, it must be endothermic or exothermic. So the temperature go from 28 to 36. So the temperature increase. So when temperature increases, what is it? Temperature increase, we learned in the lesson number 1, it is exothermic. Okay, it is exothermic reaction. So that's it. Okay, so if you can do this, you are able to score 1 mark. Okay, so next one, why they use the polystyrene cup in this experiment. So why they use polystyrene cup? Okay, so I said just now, so why we use polystyrene cup? Okay, polystyrene cup is used to reduce. Okay, you can use the word reduce. If you don't want to use the word reduce, you also can use the word minimize. Okay, you want to reduce heat loss to the surrounding. Okay, because like what I said, we want all the heat to stay inside the cup. We want the heat to stay in the cup. We don't want the heat to run away from the cup. We don't want. So when we use the plastic, so the plastic can minimize, okay? So only very little heat will run away, okay? So we want to minimize the heat that will run away from the cup, yeah? So that's it, to reduce or minimize the heat loss to surrounding. And I said what? Don't use prevent, you cannot use prevent, only use the word reduce or only use the word minimize, yeah? So next one, you need to write a balanced chemical equation for this reaction. So let's write a balanced chemical equation. So we have zinc react with copper sulfate. So let's do it. Zinc is Zn, copper sulfate is CuSO4. So this is a very simple gangster bully concept. Zinc is a more powerful gangster than copper. Why? If you look at ECS, zinc is higher than copper in ECS. So when zinc is more powerful, zinc will kick the copper out. So the copper you kick out. So now the zinc will take the sulfate. You will get zinc sulfate. So I hope you know how to write this chemical equation, yeah? So this chemical equation, you must make sure it is balanced. Okay? So that's it. So after we have a balanced chemical equation, so now the next thing, so now we need to do a calculation. So now we need to do calculation. Right, so to do calculation, we follow the step here. So the first thing, the question asks us to find the energy, the heat energy released in this experiment. So if the question asks you to find heat energy, if the question asks you to find heat, is Q, okay? They ask you to find Q. So how to find Q? So we will try Q equal to MC theta first, okay? We'll try this formula first, Q equal to MC theta, okay? So fill in the blanks, So do we know the M? M is the mass. So in this chapter, the mass is referred to the solution. So we want to find the mass of solution. The mass of the solution same as the volume. The mass of the solution same as the volume of solution, which is 50. Which is 50. So with the mass is 50. C is heat capacity, is given 4.2. Theta is the temperature change. To find temperature change, take the higher temperature minus the lower temperature. So the higher temperature is 36, lower temperature is 28. So we take 36, okay, minus 28, yeah? So then only we key in the whole thing into your calculator, yeah? Now we key in the whole thing into your calculator. You will get the final answer to be 1,680, yeah? That is the value. And not to forget to put a proper unit. You must always put a proper unit. So what is the unit? So we are looking for Q. Q is heat energy. Heat energy, the unit is joule. Yeah? That's it. So if you can do this calculation, you will get 1 mark. Yeah? So next one, we want to find the mole for copper 2 sulfate solution. Yeah? We want to find the mole of copper 2 sulfate solution. So how to find the mole of copper 2 sulfate solution? To find the mole of solution. So which formula we will use? N equal to mv over 1000. So this is the formula to find the mole of solution. So the M is the molarity, okay, the concentration. What is the concentration here? The concentration is 0.2, okay, volume is 50. So we take the value here, okay, we take the value 0.2 as the molarity. The volume, okay, is 50, yeah. Then we divide by 1000, yeah. So then same thing, we key in the whole thing to your calculator, yeah. So when we key in the whole thing to the calculator, you should get how much, okay? If you can key into the calculator, okay, so you will get 0.01. And don't forget about the unit again. What is the final unit? Since we are looking for mole, the final unit is supposed to be MOL. Yeah, that's it. So next one. Okay, so now we want to find the heat of displacement. So we want to find heat of displacement. So how to find heat of displacement? When you see the word heat of, so you know you want to find delta H. When you see heat of, we are looking for delta H. So we want to find delta H. To find delta H, okay, the formula must be plus minus Q over N. So now, do we know the Q? Yes, Q, we found it just now. The Q is 1680 joule. So we have 1680 joule. And not to forget about the plus minus. Plus minus depends on endo or exo. This reaction just now we answer that we know it is exo. Exo it's negative. So exo we should put a negative here. So now we need to divide by N. N is mole. What is the mole that we are looking for? So this is heat of displacement. Displacement, gangster bully concept. So in gangster bully concept, we need to kick the metal out, right? We want to kick out the metal. So this mole is the mole of the metal, okay, that is displaced. This is the mole of the metal that we kick out. So do we know which metal we kick out? I will say yes. By refer to the equation here, we know that we want to kick out the copper, right? We want to kick out the copper. So this is the metal we kick out. So we want to find the mole of copper. So what are the information we know? Just now the question asked us to find the mole of copper sulfate. So we already know the mole of copper sulfate, you see. So we know the copper sulfate is 0.01 mole. So when we know the mole of copper sulfate, we can find the mole of the copper that we kick out, right? Okay. When we know the mole of copper sulfate, we can find the mole of copper by using ratio. Okay. When we know the mole of one substance, we can find the mole of another substance using ratio. So the ratio is 1 to 1. So 1 to 1 means they are the same, 0.01 mole. So now we know the mole of the metal we kick out is 0.01 mole. Okay. So we just key in, we just put it back to the formula here. Okay, so 0.01 mole. Okay, so key in to the calculator. Yeah, so now we just key in the whole thing to the calculator. Okay, we will get minus 168,000. Don't forget the unit. This is joule, this is mole. So we get joule per mole. But this is not the final answer because I said just now, delta H, the final unit must be kilojoule per mole. The final unit should be kilojoule per mole. So how you can change the joule to become kilojoule? Okay, so this is more on physics, a simple calculation. To change mole to kilojoule, we move 3 steps to the left. Okay, we move 3 steps to the left. So the final answer would be negative 168 kilojoule per mole. Yep, that's it. Okay. All right. So the next one is this. Okay. So the next one, now we need to draw energy level diagram. Okay. So like what I say in the first lesson, you must know how to draw energy level diagram. So energy level diagram is the staircase. So how to draw the staircase diagram? Okay, so you need to draw y-axis first and label as energy. Okay, then you need to draw the first staircase. Okay, so the first staircase, you must put the reactant on the arrow here. So what is the reactant? So look at the chemical equation that we have. This is the reactant. So we copied it. So we copied it. Zinc plus copper sulfate. So now you must know your staircase is going down or going up, right? So how to know? Look at the delta H. So the delta H we calculate to be negative 168. So when the delta H is negative, negative will go down. Yeah, so we will go down. Okay, then we draw another one more line. Here we put the product. So where to put the product? From our chemical equation just now, copy the right hand side. Yeah, so the right hand side we copied it. Yeah, ZnSO4 here and the copper here. So we are done. And don't forget, you need to label here. Okay, so the gap between the staircase here, this is your delta H. You must label the delta H here. Okay, so let me label it. So this is your delta H. So the delta H we calculated just now, negative 168. So you must label negative 160, and the unit kilojoule per mole. Okay, so in this question, if you can draw the energy level diagram, you will get rewarded by 3 marks. You will get 3 marks, okay, which is very, very good. Okay, it's very good, it's very rewarding. Yeah, it's very good and very rewarding. So the next question, this is a very good and this is a very popular question. Yeah, they ask you to predict the value for heat of displacement if the magnesium is used, okay, to replace the zinc powder, and they ask you to explain why. Okay, they ask you to explain why. Okay, so which means what? Initially we use the zinc plus copper sulfate. Now we want to change the zinc to magnesium, okay, and copper sulfate. So they ask you to predict the heat of displacement. Okay, so here I want to teach you a very important concept. I need you to understand a very important concept, which is this. Okay, so you need to understand that, okay, the greater the distance, okay, the greater the distance between two metals, the greater the distance between two metals in the electrochemical series. The greater the distance between two metals in the electrochemical series, okay, the greater the heat of displacement. Okay, so this is the concept. If the two metal in the ECS, the gap is bigger, so the heat of displacement also bigger. So look at it. So you see just now we have this. Okay, so this is our ECS that you must know. So just now we are using the zinc to bully the copper, right? Just now we use the zinc to bully the copper. So you see, this is the gap. So how much it is just now? Negative 168 kilojoule per mole. So where we get the value? We calculate just now, right? We calculated just now. Okay. So now if they change the zinc with magnesium, so what happened? If they change the zinc now with magnesium, so now we have magnesium and copper. So now you look at this one, magnesium and copper. So can you see the gap now is even bigger, right? So now you can see a bigger gap, right? Okay, the gap now actually is become bigger already. Yeah, the gap become bigger. So if the gap become bigger, so what will happen to the heat of displacement? So the bigger the gap, okay, the greater the distance, the greater the heat of displacement. Okay, so a simple thing, you remember this: big gap, big energy. Okay, big gap, big energy. So if the gap is bigger, the energy is more. So now we know already. So the energy now should be more than negative 168 kilojoule per mole. Okay, more than negative 168. That's it. Okay, so the negative here only tell you it is exo. It is exo. Okay, all right. So some people say, sir, I thought more than negative 168 means what? Negative 200. I thought mathematics negative 200 is smaller than negative 168. No, the negative here only tell you is exothermic. So when we compare the number only. Yeah, for example, this is 168. This one, the number may be 200. Yeah, that's it. So but do you need to know how much is the number here? No need. You don't need to know the number here, because some people say, sir, more than minus 168 is how many? It's 169. 200, 240. How I know? Okay, so you don't need to give a proper figure. You don't need to mention, oh, it is negative 700, it is negative 200. No need. Okay, you just need to mention it is more than negative 168 kilojoule per mole. That's it. Yeah, so if you write this, you get 1 mark. Yeah, you get 1 mark. Okay, you need to explain why. So why? Okay, why the heat of displacement is even greater. Okay, why the heat of displacement is even greater. Okay. Okay, so now after you get this, you get 1 mark lah. But here to get another 1 more mark, okay, it's 2 marks, right? So here is 1 mark. To get another 1 more mark, we must explain why. So why the heat is more? Okay, because as you can see here, okay, the gap is greater, right? The gap is greater, but we don't use the word gap. Okay, so from here you can see magnesium is even higher than zinc, right? Magnesium is higher than zinc, which means what? Magnesium is a more powerful gangster. Okay, so when we use even a more powerful gangster, the heat of displacement will be even greater. True or not? You see, initially zinc is more powerful gangster than copper already. So this is the gap, minus 168. But now when we change the zinc with magnesium, magnesium is even more powerful gangster than the zinc. So therefore, you can see the gap is even greater. Yeah. So how you explain it? Okay, you just need to write this word. Okay, you just need to write, okay, magnesium is more electropositive than zinc. Okay, means magnesium is even more powerful gangster than zinc. Alright, so you can see initially we have zinc and copper. So zinc is a powerful gangster. Zinc can bully copper. So this is the gap. Now if you change the zinc with magnesium, magnesium is even more powerful gangster. So when magnesium is more powerful, the gap is even bigger. So when the gap is even bigger, more energy. So how to explain this? You just need to mention that magnesium is even a more powerful gangster than zinc. But like what I say just now, you cannot say gangster, right? You have to say magnesium is more electropositive than zinc. Okay, that's it. So if you can write in this way, then you will be able to get your full marks already for this question. Yeah. All right. So I hope you can see. All right. So in this question, this is something we call structure question. So this question, how many marks you can score if you can answer, if you can do all. This is 1 mark. This is 2. This is another 2. You have 4 marks already. Then we have 5, 6. Okay. Then we have 7. 7 plus 3, 10. Okay. Right. 10 plus 2, 12. Okay. So that's a lot of marks. So if you know how to answer this kind of structure question, you can score easily between 6 to 11 marks. Okay, you can, so the mark can go between 6 to 11 marks. Okay, so you do it step by step, you should able to solve all the question. Okay, like this. Okay, so let us continue with another question. Okay, so now this question also follow the SPM format. So you can expect they will ask the question like this. The way they can ask the question, the format of the question will be something like this. Okay, in your SPM. Okay, so let's start. Okay. Alright, so diagram 2 show the apparatus setup to determine the heat of displacement. So you see, we want to get the heat of displacement. Okay, so as you can see, yeah, we have a plastic cup. Yeah, so inside the plastic cup we have copper 2 sulfate, which is the salt solution, and then we also put the zinc powder, yeah, which is the more powerful gangster. Yeah, the more powerful gangster. Yeah. Alright, so let's do this question together. Yeah. Okay, so now you are given some information. Okay, you are given the temperature. Initial temperature is 28.5. The highest temperature is 33.5. Okay, so they also give us the specific heat capacity. They also give us the relative atomic mass, RAM. Okay, so let's start with this question. Let's start with this question. Okay, so the first question is asking us, based on the experiment, what is the heat of displacement? Okay, so if you recall, what is the definition for heat of displacement? Okay, what is the definition for heat of displacement? Okay, so if you look back the previous part, okay, this is the definition. Alright, come back to here, the front part. Okay, so heat of displacement is here. Heat of displacement is the heat change when 1 mole of metal is displaced from the salt solution by a more electropositive metal. Okay, so this is the definition. Okay, alright, so now we just need to copy this whole thing. Okay, but we need to modify. Okay, so let's copy it first. So heat of displacement is the heat change. Okay, is the heat change when 1 mole of metal. Do we know what is the metal that is displaced? Do we know what is the metal, okay, that we kick out? Okay, because we want to kick out 1 mole of metal, right? Do we know which metal we want to kick out? I will say yes. Why? Zinc is more powerful gangster than copper, right? If you check your ECS, okay, so this is your zinc and this is the copper. So zinc is higher than copper in ECS. So zinc is a more powerful gangster. So when zinc is more powerful gangster, zinc will kick the copper out from the solution. Okay, so we want to kick out the copper. So when 1 mole of copper, okay, is displaced, so we kick the 1 mole of copper. Okay, where we kick out the copper? We kick out the copper from the salt solution. Okay, do we know what is the salt solution? Yes, the salt solution is copper to sulfate. So from copper to, from the copper to sulfate solution. Okay, so when we kick out 1 mole of the copper from the copper to sulfate solution. Okay, now the last thing, okay, you must mention who kicked the copper out. Who kicked the copper out? So if you want to kick the copper, you need a more powerful gangster. So in this question, who is the gangster? The zinc. Yeah, so by zinc. Yeah, so some student will ask, sir, should we write the zinc powder? No need. You don't need to write the word powder. You just need to tell who is the metal that kicked the copper out. But if you write the word powder, can or cannot. If you want to write the word powder here, okay, no problem. But you don't need to do that. Yeah, you don't need to put the word powder. But if you want to write that, it's okay. Yeah, if you want to write that, it's okay, no problem. Yeah. So next one. Okay, so for the next question, we want to write ionic equation for this reaction. Okay, we learned about ionic equation in your Form 5, Chapter 1. What is ionic equation? Ionic equation is the equation that got ion. Okay, so the equation must got charge. So I hope you can remember how to write the ionic equation. Yeah, so we learned in your Form 5, Chapter 1, we can start with a chemical equation. Then only we convert the chemical equation to become ionic equation. Yeah, we learned this in Form 5, Chapter 1. Yeah, so let's do it. So let's start with writing a chemical equation first. Zinc powder is Zn. Copper sulfate is CuSO4. Yeah, so zinc is a more powerful gangster than copper. Zinc will kick out the copper. So we kick the copper out. And then zinc rob the sulfate away. Zinc rob the girlfriend of the copper, which is a sulfate. So when zinc combine with sulfate, we get zinc sulfate. Yeah, so this is chemical equation. So to change chemical equation to ionic, we must list out the charge. Zinc is one species element. All the element, anything has one species, they have no charge. Anything has one species, they have no charge. Okay, we learned this in your Form 5, Chapter 1 as well. So zinc has no charge. Copper is Cu2+. Sulfate is SO4 2-. Okay, that's the left hand side. So right hand side, the zinc is Zn2+. The sulfate is SO4 2-. So the copper here is one species element. The copper only has one species is element. Element has no charge. So if you compare the left and the right, we can see that the sulfate don't have any changes. So you cut it off, okay? So after you cut off, so the remaining answer is the ionic equation, okay, which is Zn plus Cu2 plus to become Zn2 plus and Cu. Okay, so if you really forgot already, please revise back your Form 5 chapter 1. Please revise back the Form 5 chapter 1, the redox, yeah, because this is a very important skill. Okay, everyone must know how to convert the chemical equation to become ionic equation. Yeah. Okay, next one. So they ask for observation. So observation is what we can see, yeah? What we can see. So for observation, you can refer to the half equation. So the first one you can see is this. Zn becomes Zn2 plus. When Zn becomes Zn2 plus, when the metal become ion, it means they dissolve. Okay, when you see a metal become ion, it means they dissolve. So you can write this answer. So zinc is a metal, it changed to ion, so it dissolves. So who dissolve? Zinc powder. So you can say zinc powder dissolve. Okay, zinc powder dissolve. That is one of the observation. If you don't want to write this, you also can write another one. Cu2 plus produce Cu. So when you produce a copper, so copper is a metal. So all the metal you will see a solid. You should be able to see a solid. So what is the color? Okay, what is the color of the solid? So copper, the color should be brown. Copper, the color should be brown. So you should able to see a brown color solid. Okay, and the brown color solid is sticking at the bottom here. Okay, the brown color solid, the copper, will stick at the bottom. So you can write this. Okay, you can write brown solid, okay, is deposited. Okay, the brown color solid is deposited. Okay, so this is how you can write the answer. Okay, all right, so we have two observations here. You just write one of it. Okay, if you don't want to write this, there's another answer you can write also. Okay, so you see we have Cu2 plus initially. So Cu2 plus is inside the solution, copper 2 sulfate. So we know when the solution got Cu2 plus inside, the color should be blue, right? When the solution got Cu2 plus inside, it should be blue. So when your solution you have Cu2 plus initially, we have blue color. So now we can see the Cu2 plus convert to Cu, right? As you can see here, the Cu2 plus converted to become Cu. So when the Cu2 plus convert to Cu, the Cu2 plus become lesser, right? You see, the Cu2 plus here becomes Cu. Cu2 plus here becomes Cu. Okay, so you can see the number of Cu2 plus become lesser and lesser. So when the number of Cu2 plus become lesser, the blue color also will become lesser. Okay, so you can write, okay, the blue color of the copper 2 sulfate solution. Okay, the blue color of the copper 2 sulfate solution become paler. You can say paler, or you can say colorless. Okay, you can also say colorless. Okay, so the blue color become lesser. Okay, why? Because initially the solution have many Cu2 plus. Okay, so the color is blue. Now some of the Cu2 plus convert to become Cu. Okay, yes, as you can see from the equation, some of the Cu2 plus convert become Cu. Okay, when some of the Cu2 plus become Cu, so the number of Cu2 plus become lesser. When we have less Cu2 plus, the blue color also become lesser. Okay, all right, so that is how we give the answer. Yeah, so we have three answers here. You just write one answer will do. Okay, so next one. So now after we go through all the theory, now we will continue with the calculation. We will continue with the calculation part. So for the calculation part, the first question, they ask us, based on the experiment, we need to calculate the heat liberated. Okay, So heat, they are looking for heat. Heat means Q, yeah. Always remember, if they ask for heat, is Q. Heat of is delta H, okay. So the heat is Q. So we know the formula should be Q equal to MC theta, yeah. Q equal to MC theta. So let us substitute the value. The M is mass. So in this chapter, in thermochemistry, the mass is referred to the mass of the solution. Mass of solution is exactly same as the volume of the solution, okay. So what is the volume of the solution here? 50, yeah. So the volume is 50. So C is the heat capacity, which is given here. The heat capacity is 4.2, okay. So 4.2, okay. All right. So now the last thing that we need is the theta. Theta is temperature change. So how to find temperature change? Take the high temperature to minus the low temperature. Okay, so take the high temperature 33.5 minus the low temperature 28, okay, 0.5. Okay, all right. So key in this to your calculator, you will get 1050, okay. And please don't forget about the unit. When you do calculation, the unit is important. We are calculating the Q. Q is the heat. Heat is a type of energy. Energy, the unit must be joule. Okay, so please remember the unit. Heat, the unit is joule. Delta H, the unit is kilojoule per mole. Okay, I'll keep on repeat this. Okay, I'll keep on repeating this. Hopefully you can get this idea as soon as possible. The unit is very important. Yeah. Okay, next one. Now the next thing, we need to find the number of mole of copper form. Okay, how to find the mole of the copper? Okay, now do we given any information about the copper? Okay, do they give us the information for copper? No, right? They only give us copper 2 sulfate. They only give us copper 2 sulfate. They never give us the copper. So how should we do the question? So if they give us other information, so how are we going to do the calculation? Okay, just like this. If I give you the information about durian, but I want you to find rambutan, so what you should do? Okay, if I give you the information about durian, but I want you to find the mole of the rambutan, so how to do it? So if let's say they give you different information, you must write chemical equation first. Okay, so we must write chemical equation. Okay, so the chemical equation is Zn plus CuSO4 become ZnSO4 plus Cu. Please don't memorize the equation. Yeah, don't memorize the equation. You must understand how to get this equation. Okay, so after that, you must ask yourself what you have and what you want. Okay, what are the information you have and what are the information you want? Copper sulfate, we have the information, we have the volume is 50, and we have the molarity, which is 0.5. Okay, so from here you can write volume, it is 50, concentration, the molarity is 0.5. Okay, so this is the information that we have. What is the information that we want? We want to find the mole of copper. So this is the copper, and we are looking for the mole. Okay, so how to do your chemistry calculation? So chemistry calculation always start with the mole. Always start with the mole. So when you see M and V, okay, if the question gives you M and V, it means the question is a solution. When you see M and V, you know that it is a solution. Can we find the mole of the solution first? Yes. So the mole of the copper sulfate solution, you can find using the rate. You can find using the formula mv over 1000. So the formula N equal to mv over 1000. This is the formula to find the mole for the solution. So the M is the concentration 0.5, the V is the volume 50 divided by 1000. Okay, all right. So key in this to the calculator, you should get 0.025 mole. But this is not the final answer. This is the mole for copper sulfate. So now we found the mole for CuSO4. But now you ask yourself, is the question looking for copper sulfate for this? Okay, is the question ask us the mole for copper sulfate? The answer is no. The question wants us to find the mole of copper, not the copper sulfate. So what you should do, now you know the mole of the copper sulfate already, which is 0.025. Now you want to find the mole of copper, so you should do ratio. Okay, you should refer to the ratio. So the ratio of the copper sulfate and the copper, as you can see in the question, is this. Copper sulfate, the number in front is 1. Okay, so for the copper, the number in front also 1. So the ratio, it is 1 to 1. So 1 to 1 means same. So the mole should be the same. Okay, so the mole of copper should be the same as the copper sulfate. Okay, so let's do it. So the mole of the copper is exactly the same as the copper sulfate, which is 0.025. Okay, 0.025. So now we get the answer already. Okay, so it's not very hard, but just do it slowly and just do it carefully. Okay, so now we are done. So the next question that we need to find is this. So now we need to find the heat of displacement for this reaction. So when you see the word heat of, so we know you are looking for delta H. When you see heat of, we are looking for delta H. So the formula is delta H equal to plus minus Q over N. So now we just need to fill in the blanks. So just fill in the blanks. Okay, so we should use positive or negative here. Positive or negative depends on the reaction is endothermic or exothermic. How to know the reaction is endo or exothermic? Okay, so this question, they never use the word endothermic or exothermic. They didn't tell us directly. So they didn't tell us, hey, this is endothermic, this is exothermic. The question never tell us. So if the question never tell us directly, how are we going to know it is endo or exo? We can look at the temperature. Okay, by referring to temperature, we will know it's endo or exo. Initial temperature is 28.5. Highest temperature is 33.5. So the temperature increases. So when temperature increase, it is exothermic. Okay, always remember, temperature increase is exo, temperature decrease is endo. Yeah, so this is very, very important. Okay, so let's do it. So since we can see the temperature increases, we know this is exo, we put negative. Okay, so what about the Q? So the Q, we found already Q just now. The answer, it is 1050. Okay, so it is 1050. And don't forget to put the unit. What is the unit for the Q? Joule. Okay, the unit for the Q is joule. So divide by N. N is mole. Okay, N is mole. Okay, what is the mole that we want? Heat of displacement. Displacement, what it is? Displacement means gangster bully concept. You want to kick the metal out. Okay, gangster bully. The more powerful gangster kick the less powerful gangster. So the N here, it is the mole of the metal that is displaced. Okay, the mole of the metal that we kick off. So do we know what is the metal we kick off? In this case, I will say yes. We kick out the copper. Okay, the zinc go in and kick the copper out. Okay, so copper is the metal that we displace. Copper is the metal that we kick out. Do we know the mole of the copper that we kick out? Yes. We found it just now on the previous question. The mole of the copper that is kicked out is 0.025. Okay, so the copper, it is 0.025. Okay, don't forget to put the unit here. So the unit is mole. Okay, so now you already have the answer. So you already have the value. Now you need to do your calculation. So if you key into calculator, you are getting negative 42,000. Okay, the unit is joule and mole. Okay, so it is joule per mole. But we are not done, because the final unit, the final unit for delta H, for delta H, the final unit should be kilojoule per mole, So how to change joule to kilojoule? Okay, so we move 3 steps to the left. Okay, we move 3 steps to the left, so we will get negative 42. Okay, so this is negative 42 kilojoule per mole. Okay, so I hope you can understand how I do the calculation here. Okay, all right, so it's not very hard, just do it using the proper formula. Okay, so now let's continue. Okay, so we almost done already. So now the next one, why we use zinc powder in this experiment? Okay, why we use powder? Why we don't use a big piece of zinc like this? Okay, one zinc like this. Okay, why you don't use a bigger pieces? Okay, so we learn this in your Form 4, Chapter 7, rate of reaction. So we learn that powder has a faster reaction. Okay, why we use the zinc powder? Okay, all right. So we use the zinc powder in order to speed up the reaction. Okay, in order to speed up the reaction. Okay, so if you want to make the answer even perfect, you can write this. Okay, so why the powder can speed up the reaction? Okay, we learn this in your Form 4, Chapter 7. When we use powder can speed up the reaction because what? Powder has a larger total surface area. Okay, so because it has a larger total surface area. Okay, when we use powder form, the surface area is greater. So when we have more and more area, we have more collision. Yeah, we have more collision. Okay, so this is something we learn in your Chapter 7, Form 4. Okay, all right. But in SPM, if you write until here, normally you get full mark already. But for me, I want the answer to be as good as possible. So if possible, you write the whole thing like this. Okay, if possible, you write the whole thing is even better. Yeah, to speed up the reaction because it has larger total surface area. Okay, so the next one. Okay, so the next one, you need to draw the energy level diagram. Okay, energy level diagram. So it is level, one level. It is the staircase. So now we need to draw the staircase diagram. So how to draw the staircase diagram? So first of all, we draw the y-axis. So the y-axis, it is energy. So you draw the first line as the reactant. So what is the reactant here? So the reactant here, you can write zinc and copper sulfate. Okay, some student will ask, sir, if I don't want to write chemical equation, can I write in the ionic equation form? Yes. Okay, you can write chemical equation or you can write ionic equation, no problem. Okay, so let's say we use ionic equation. Okay, let's say since this question asks us to write ionic equation, so we will use the ionic equation. Okay, so we put in the reactant here first. Okay, zinc plus Cu2 plus. Okay, all right. So now you must know the ladder will go up or the ladder will go down. So the delta H is negative 42. Negative will go down. So remember, negative will go down. So remember to draw the arrow. So you draw another one more line. So what is the product? Copy back the product here. Zn2 plus and Cu. Okay, so the product, it is Zn2 plus and Cu. Okay, so now we already get the product. And not to forget, you must label your delta H. So where is the delta H? Delta H is the gap of the staircase here. Okay, this arrow. So this arrow is your delta H. So put the delta H first. So in this case, what is my delta H? So my delta H is negative 42 kilojoule per mole. Okay, so put in the value and put in the unit. You must put the value and unit. Okay, so now we are done. Yeah, we are done. Alright, so that is how we get the energy level diagram, okay, which is what we learned in lesson number 1. In lesson number 1, I teach you how to draw energy level diagram and energy profile diagram, okay. So this is very important. In SPM, they always ask us to draw energy level diagram, so you must know how to draw your energy level diagram, okay. So now we go to the last 2 questions for today's lesson. Okay, this is the last 2 questions. Okay, so now you can see here. Okay, this is a very popular question. Okay, this is a very popular question. So the question say that the heat of displacement of copper that we obtain is different from the standard value. Explain why. Okay, what do we mean? It means that the heat of displacement that we get, okay, the heat of displacement that we get from the experiment is always lesser, is always different compared to the standard value. Standard value means what? Theoretical value. Okay, theoretical value. Why is different compared to theoretical value? Okay, we need to explain why. Okay, so the question gives us 2 marks here. So there are 2 points you should write. Point number 1. Point number 1, you must mention how does the heat different from the standard value. Okay, so remember, standard value is always the theoretical value, the value in theory. When we do experiment, you must understand all the heat that we calculated, all the heat that we get during experiment always lesser. Okay, I repeat, all the heat that we get in experiment always lesser than the theoretical value. Okay, so let us write it out first. Heat of displacement, okay, of copper, copy back, heat of displacement of copper obtained is lower. You can write lower or you can write lesser, okay, than standard value. Okay, so this is the first point. Okay, you must mention the value for the heat that we get always lesser than the standard value. Okay, why the heat is lesser? So as what I mentioned to you previously, when we do any experiment that involve heat, okay, when we do any experiment that is involving the heat, okay, so like heat of displacement, heat of neutralization, heat of combustion, heat of precipitation, all the experiment involve heat, the biggest challenge, okay, the biggest problem is always heat loss to surrounding. Okay, the heat will run away to surrounding. Okay, so for example, theoretical, okay, theoretical, you expect you should have 70 joule. Theory, you should get 70 joule, but when you do experiment, you will never get 70 joule. Why? Some of the heat will run away to the surrounding. When some of the heat run to the surrounding, maybe when you do calculation, you only get 65 joule. You get it? Okay. By right, according to theory, you should get 70 joule. But when you do calculation, you only get 65 joule. Okay, you only get 65 joule. So you see, it's always lesser. The value that we get is always lesser. Okay, so why the value is always lesser? Because some of the heat run away to the surrounding. Okay, so you can write this because they are heat loss to the surrounding. That's it. Okay, so I want everyone to know this. The biggest challenge that we are facing during the experiment of heat, when we do any experiment of heat, so there is always some heat loss to the surrounding. Okay, there are always some heat loss to the surrounding. So when there are some heat run away to the surrounding, your final answer always lower, okay, or always lesser than the standard value. Okay, all right, that's it. So suggest a way to reduce the difference. So how you can reduce the difference? So like what I say, the biggest problem is always okay, the biggest problem is always heat loss. So we need to suggest what we can do to reduce the heat loss. What we can do to reduce the heat loss. Okay, so here we have two methods we can reduce the heat loss. Okay, so one of the method is this. Although here we use a plastic cup, so the heat loss here is a bit lesser, but as you can see, the cup here is open, so all the heat can go out from here, right? Okay, all the heat can run away from here. So if you want to minimize the heat loss, if you want to make the heat loss lesser, you can put a cover. Yeah, you can just put a cover, because when you put a cover, the heat that go out is a little bit lesser. Yeah, so one of the method you can do is you can put a cover. Okay, you can put a cover. Okay, that is one of the method. Okay, all right, so put a cover, and make sure the cover also made from the material that can reduce the heat loss, such as a plastic. Put a plastic, or you can call it a polystyrene cover. Yeah, make sure the cover also made from the material that can reduce the heat loss. Okay, so what material can reduce the heat loss? Plastic. We can use plastic material or polystyrene material to reduce the heat loss. Okay, so this is one of the method that we can use, okay, to minimize the heat loss to the surrounding. Okay, yeah, so I think that's it. Okay, so I hope you understand what we are learning in today's lesson. Yeah, so in today's lesson, I teach you the basics idea of the heat. So I covered the basic concept for heat. Okay, you must make sure that you use N equal to MV1000 when you want to calculate the mole for solution. When you want to calculate thermochemistry, when you want to play with heat, you must play with only two formula. Okay, Q equal to MC theta, delta H equal to plus minus Q over N. So these two formula is super important. Okay, so if this method cannot use, then you have to go for this. Okay, if this method cannot, then you have to go for this. That's it. It always these two formula only. We always rotate. We always change between these two formula. If this formula cannot use, then it must be this. If this formula cannot use, it must be this. That's it. Okay, it's a very simple one. So in today's lesson, we covered 5 examples. I show you 5 examples on how they do the calculation. So I want you to revise back and make sure you can do all the 5 examples on your own. These are the 5 examples that we learned just now. Okay, all right, so if you can do these 5 calculation, you should be fine. Okay, so after the 5 example, I show you 2 question. Okay, 2 question, okay, of heat of displacement that is coming from your past year paper. Okay, so this is the real format they can ask you about the heat of displacement in your exam. You can see, all right, that is how they ask you. Not very hard, and it is very rewarding. Many marks one. Okay, normally if they want to ask you heat of displacement in subjective, normally it will go between 6 marks to 11 marks. Okay, so there's a lot of marks you can score if you understand the concept. Okay, and as you can see, they really love to ask you to draw energy level diagram. You can see both of the question here also ask you to draw energy level diagram. Okay, that's why I keep emphasize in lesson number 1, you must know how to draw your energy level diagram. Okay, so I think that's it. So I hope you understand what we are learning so far, because if you fully understand heat of displacement, it will be very easy. Okay, if you fully understand heat of displacement, okay, it will be very easy when I teach you these 3. Okay, when I teach you heat of neutralization, heat of combustion, heat of precipitation, it will be easier because many concepts from here you can use in other heat as well. Okay, that's it. All right, so I think that's it. Okay, so that's all what we need to learn in today video lesson. Okay, so I will see you. Okay, I will see you in the next lesson then. Yeah, all right.